Hello everyone, welcome back to CCA 175 Hadoop and Spark Developer Preparation video series. Today I'm going to walk you through the solution of problem number 2 posted on my blog site. The website address of my blog is available in the description section of this video. The first step of problem 2 is asking you to download the data that is available in the products table into products folder on HDFS. It is also asking you to pipe delimit the data. So let's go to the terminal on our Cloudera VM. Okay, I have pre-typed the scoop command. It has a scoop import, connect using the connection string to retail DB database. It has a username, password. The table is products. We want to download it as a text file. Target directory is Cloudera products, and the fields should be terminated by pipe. So let's try to run this command and see the result. Okay, the command has executed. Um, as you can see, the trace of the command here. Let's try to confirm if the folder has been created with the required files. So let me quickly do ls on the folder, Hadoop FS ls user Cloudera. I should see a products folder created now. As you can see, I can see a products folder. Now let me get into the products folder and view the details or view the child elements of it. So we have 4 files created. I would like to investigate what is there in one of those files just to make sure that data is in fact copied in a pipe delimited way. Okay, as you can see, there is a pipe delimiter. Now this concludes step number 1 of the problem. Let's look at step number 2. Step number 2 is asking you to move all of the data from products folder into problem 2 products folder. Now this is to test your HDFS command skill. So all you need to do is to first create the required directories because there is no directory named problem 2 so far on the HDFS. Okay, so let's try to create products folder under problem 2 folder. Okay, so now you have the required directories. Now let's try to copy data from the user Cloudera products folder into user Cloudera problem 2 products folder. All you need to do is use a cp command and it kind of copies. Okay, now let's look into the user Cloudera products folder and confirm that the data has been in fact copied. Okay, so I have the data, so I can get rid of the original products folder so that I can save some space on my disk. So -rm is remove, -r is recursive, and -f is force. Now these 3 commands put together are going to delete the products folder successfully. Now let's look at the next step in the problem. Let's look at the next part of the problem. This is asking us to change the permission of all the files that we just copied into the new folder. Um, we have to change permissions in a specified format. Let's investigate about what kind of permissions exist currently for all of these files under this folder. For this, all I need to do is to do an ls with -h, which is human readable format, and then specify the folder name. Oh, sorry, I specified the wrong folder. I need to say Cloudera slash problem 2 slash products. Okay, as you can see, the current permissions are slightly different than what the problem is asking you to do. So for that, let's look at the problem again, or let's look at, let me give you a brief overview of how this permissions thing work. Again, the first set of permissions is on the owner, the second set is group, and the third set is others. Okay, so I use the Hadoop fsls command, and I got the below result, as you can see, right? So the first set is the first three characters talk about the owner, the second three group, and the last three are others. Okay, so 4 is for read, 2 is for write, and 1 is for execute. So in order to give read, write, and execute permissions, you need to sum up 4, 2, and 1, which gives you read, write, and execute permission. And we need to use chmod function in order to execute, in order to change permissions of the file. So all I'm going to do is chmod. Uh, 7 is for the owner group. For the owner, it is seeking us to provide read, write, and execute on for the owner, right? So the first set of values is owner. I'm going to give 7. And then it is asking us to give read and write permissions to the group. Okay, now read is 4 plus write is 2, so 6. So I'm going to give 6 for the group. Okay, so I'm going to give 6 here, 7, 6. Now the third one is just read and execute permissions for all of the users. For this, all I need to do is read is 4 plus execute is 1, so 5. So I'm going to do 7, 6, 5, 5 in order to change permissions of the files that we have under problem 2 products directory of HDFS. Do an ls again to confirm that the permissions of these files have changed. Okay, yes, they have. As you can see read, write, execute for the owner, whereas earlier it was read, write, and nothing. And you can see that it's read, write, execute for the owner. You can see the same thing for remaining. Okay, 4 plus 2 is 6, read and write, and read nothing, execute is 4 plus 1, which because there is no write permission over here. So this is how you change permission. Now let's look at the next part of the problem. The next part of the problem is asking you to use the data that is available in the products folder and perform some operations using three varieties. One is by using data frames, other is by Spark SQL, and other is by aggregate by key. You'll have to do filtering and you will have to do aggregation. So first part is to filter so that we can get only products whose price is less than 100, and among those products we need to find the highest value. You need to find the total, you need to find the average and minimum. So let's get started solving this problem by going into the Cloudera's VM. Uh, okay, before we get into solving this problem using Spark, let's try to investigate how this table looks like by logging into MySQL. The reason we would like to investigate the table structure is because in order to do data frame operations, we should have good clarity on the type of data that we are operating on. And here we are trying to use a text file. Okay, this is not a Parquet or an Avro file to contain schema in it. So I'm talking while I'm logging into MySQL, so I hope you guys can catch up. Okay, so let me show tables and do a describe on the products table to see how product table looks like. Okay, it has 6 columns. Now let me load the text file, or let me create a Spark data frame backed by the data in the text file under user Cloudera problem2 slash products. Okay, and then I'm going to map each record and trying to extract all this records are pipe separated here. So I'm going to say var d equals x dot split using the pipe character, and then just create a tuple from this array, which is the result of split, and by just extracting elements at each index. Okay, so I'm going to d4, d5, and d6. Sorry, d0 to d5. Okay, so I have these. However, if you notice, all these are coming as string. Our goal is to map them to the exact data type. So let us perform one more step here. So I'm going to convert the first one into int, the second one into int. I will leave the third and fourth because they are varchar, so varchar is string. And then I'm going to convert this into float. Okay, so now if you see the RDD data types match the data types on the table. We need to have this kind of a setup in order to perform sensible data frame operations. Okay, imagine trying to do an aggregate on the string. It does not make sense, right? So that is why I converted product price into float to match the source data. If you downloaded this as an Avro or a Parquet file, then the schema would match whatever the table that was the source. Scoop would do that for you. However, you downloaded this from um, MySQL as a text file, which means everything is a text here. Now that we have our RDD, let's try to create a data frame from this. Okay, before we create a data frame, we need to have a class which represents each of these so that we can have meaningful column names. So I'm going to start with product ID, which is an integer, and then product category, which is an integer, and then product name is a string, description is a string, price is a float. Sorry, I typed integer, so let me go back. Price is a float, and then this is a string. Okay, so let's see. Okay, now we have products. Now let me convert each record in the RDD into an object of product. Okay, so where products df equals products.map x products, and I'm going to just pull all of the elements of the tuple in the same sequence because I don't even have to convert them into the right data format because we've already performed that step while creating an RDD itself. Okay, so let's see what happens now. Okay, so you can see an RDD with the column names that you wanted. Let's try to do a show on it quickly to see if the data is coming as expected. Okay, so as you can see, the data has product ID, product name, product description, so on and so forth. Now these are the column names that we wanted. Okay, now let's go back to the problem and see what is the next step. Okay, let's look at the next part of the solution. Next part of the problem. So this is asking you to apply filtering on the data frame such that we get products whose price is less than 100 USD. Filtering is very simple in Spark. All you need to do is take the data frame object and call the filter method. Okay, and I'm gonna say product price. I want to copy the name so that I don't mistype it over here. Okay, so copy product price and say less than 100. And I'm going to do a count just to see if my math is, if the filtering is working correctly. Okay, so it has 831 records. Let's try to go to MySQL and compare the result so that we have confidence in terms of the solution that we just did. So without filtering, it's 1345, and let's try to apply the filtering on MySQL. You should get a result of 831 again. 831. So this matches. Now let's take this solution forward, and the problem statement says you need to do some aggregations, the highest value, the total products, average and minimum. But one thing is common across all the aggregation. The grouping is based on category. Okay, so that needs to be determined. And let's go back to Spark Shell, and all we need to do is do a group by, and I'm going to do call of product category. Just take the product category column. Again, copy paste as much as possible because that's just going to avoid ton of um, waste time, in case you run into issues. And then I'm going to start aggregating. I know I have to aggregate 4 different values, so I'm going to do 4 calls, as a template for myself. And then for the first one, I'm going to do product price because I need to find the maximum of product price. The second is the total count of products, so sum of product IDs or count of product IDs. And then I'm going to do product price here and product price here, okay? Because the remaining aggregations are on product price. And the first one I'm going to say max, and then here I'm going to do count of distinct, and average, and minimum, which is min. So this time, let's proactively create alias names so that our result comes in a pretty format, and we have some columns that we can write to when we process this data frame further. Okay, so I'm going to do max price. I'm going to do, total products. Then let's say average price, AVG price, and for the last column, let's use min price. Okay. Okay, let's do a show quickly. Okay, as you can see, we got the result. However, even though we have the column names and everything correctly coming as per our desire, the formatting of the average price is not in a desired way. For for any amounts, we would need at max 2 decimal places. So let's try to use a round method in order to chop off the remaining decimal places and just get the first two. So I'm going to round it to 2 places, and then I'm going to capture this in a variable so that I can use the variable for further processing. So I'm going to say var data frame result, and I'm going to remove the show method so that I don't capture the result of show method. Rather, I get this entire execution, this entire stream of functions captured. So I'm going to say data frame result dot show now. Perfect, right? This is what we wanted. A perfectly formatted result with appropriate column names. Now Spark has ordered it in the way that it wanted. So that is why you see 31 as the first record, not um, product ID 1 or 2. I think product ID 2 is the starting record on this table. So let's now look at the sorting part of it. So your solution should have three, the solution should be sorted in the form of, based on the product category ID. So I'm going to say product category, which is the first column, by the way, and then enter. Then I'm going to do a show on this to make sure the result is in fact sorted. There you go. The result is sorted. The first category is 2. So you have the result in the ascending order of the product category, and then rest of the elements. So this is how you do um, you solve this problem using data frames. Now let's look at the next part of it. You know, so we have performed all the 4 steps here. I'm just confirming it, and the next part, and we have done it in the data frames. Okay, the next part of the problem is asking you to solve the same thing using Spark SQL. Now, doing this in Spark SQL is probably more easier than using the data frame API, just like we have done it in the previous problem. So let's get started. All you need to do is to take the data frame object and register a temp table. So let me find the name of the data frame object that we used earlier, that is product df. So let me just say product df dot register temp table, and I'm going to name this table as product underscore df. You can name it whatever way you want to. Now let's start solving the problem. So all you need to do is use the SQL context and SQL select star from products underscore df, and I'm going to group by product category, product category. And then I'm going to use a bunch of aggregate functions. So let me start with using max of product price as max underscore price, and then count of distinct of product ID as total products, and then average of product price as avg underscore price, and min of product price as min underscore price. Okay, and let's try to order this result by product category. Okay, because this is what your problem is asking you to do. I'll try to store this inside a variable so that I can use it for future processing. I'm going to name it as var SQL result. Okay, so you got the result, but seems like a couple of things are missing. One is we do not have the product category captured. Okay, second is the average price is not formatted. So let's try to chop off the remaining digits from here and bring only the two digits. All we need to do for that is cast this as a decimal with two decimal places. So I'm going to cast this as a decimal 10, decimal 10 comma 1, 10 comma 2, sorry, where 10 is the total number of digits and 2 is the number of decimal places. And I'm going to pull the product category as well. Now let's try to see what happens. Okay, so you have the result which is formatted, you have the product category ID, and the product category ID is sorted in the ascending order. Let's try to go back to the problem and look at what is the next step.
Okay, now that we have accomplished the solution using the SQL, let's try to do it using aggregate by key. For this, let's go back to the Spark shell and let's try to investigate the products object. Okay, so this has int, string, float, and string. Very good, because these are the data types that we want to operate on. Now the next step is to fetch the data that we need as a pair RDD, as a key and a value pair. Key should be the category ID. So I'm going to do x dot underscore one, sorry, underscore two, and then the price is 1, 2, 3, 4, 5, the fifth element in the tuple. So x dot underscore 5. As you can see, I have an int and a float, which is a key value pair. Let me now begin performing the aggregation by doing aggregate by key method. Okay, and the first value that the aggregate by key method takes is a tuple or tuple, one of the pronunciations. Um, and we are trying to aggregate four values. That is why I'm going to give four initializations. And those four initializations are for maximum price, the total count of the products, the average price, and the minimum price. That is why you can see three values as a decimal values and one value as a normal, the regular integer value. The next step is to start defining the aggregation phase. For the aggregation phase, you're going to get two values passed for every record. One is x and y. X is the previously aggregated value and y is the record itself. Here the record has only one value in it, which is a float value, right? So let me do math.max x dot underscore 1, which is the first element of the previously aggregated value, comma y. Y is the float element, which is directly coming here. So you can see x is the previously aggregated value, which is four element tuple, and then you have y, which is a floating element, okay, or element of float data type. Next, I'm going to keep incrementing the next value because that is to get the count of the products. And then I'm going to do keep aggregating all of the prices so that I can get a sum of the price and do an average a little bit later. And the third one is a minimum. Okay, good. My next step is going to be the combiner phase. This is to combine the result set obtained from multiple partitions after the processing. Now, here both x and y are going to be tuples with 4 values each. So my combiner definition is going to be different from my aggregator definition. So here I'm going to do x dot underscore 1 and y dot underscore 1. I need the maximum value among those two values. And then I'm going to add the second element because this is the total of products from each of those partitions. So I'm just going to do x dot 2 plus y dot 2, and then x dot underscore 3 plus y dot underscore 3 is the total price of all the products, and then I'm going to do math dot min. Now I deliberately left few problems in this statement. Okay? Let's try to fix the first one. The first one is you got to be careful when you are working with aggregate by key. You should have a very good understanding of what is being passed to each aggregation function. So here the problem is in the aggregation phase, the value of y is not a tuple. So I should be just doing y, instead of saying y dot underscore 3. Whereas the value of x is always a tuple with 4 elements because that is how we initialized it. Okay, so as you can see, we have an int as a key and double int double double as a value. Now let's try to store this in a variable so that we can use this variable for future processing. So I'm going to say rdd result equals, of course it needs to be a var because this is Scala and not Python. Okay, so let me take the first 5 records in the result and print it on the console to investigate if we are trending correctly in terms of creating this result properly. Now, as you can see, the result has is sorted in an order which is not defined yet. That is why you get 52 category ID as the first element. Now, and then you have rest of the aggregations. Now, let's try to beautify this further by extracting the fields in the format that we need, which is 4 fields instead of a field and a tuple. Okay. Now, let me close this quickly. Fine. So let me bring x dot underscore 1, which is the category ID, which is the key of our paired RDD. And then let's try to extract individual elements of the second value in the key value pair, right? The second position of the key value pair, which is the tuple itself. So that is why I'm going to do x dot underscore 2 dot underscore 1, x dot underscore 2 dot underscore 2, and so on and so forth. Okay, so x dot underscore 2 dot underscore 3 divided by x dot underscore 2 underscore 1, where this is the total price divided by total products in order to get the average that we are seeking. Okay, and then I'm going to pull the minimum as it is, x dot underscore 2 underscore 4. Now let's look at the result. Okay, let me take the first 5 elements. Okay, this time I got a result in a tuple of 4 elements instead of a tuple of a tuple. Okay, yeah, so now I want to order this data set. Okay, I want to order it in the ordering that the question is seeking you or asking you to do. For that, I use sort by, not order by. So order by was on the data frame, guys. Sort by is on the RDD, and I supply the element on which the RDD needs to be sorted, that is x underscore 1. Okay. Now, I still deliberately left some problems with this solution, and I'll walk you through that. But before that, let's try to identify what the problem is. Okay. So here you can see everything is sorted. So sorting looks fine. And then you can see the average and the total. So let's try to compare that with the data frame result. Okay, sorry, data frame E is missing. Okay, so I have the data frame result and I have the result from the RDD. Now, if you look at the first record, it's 299.99 1166.81 over here. So 99.99 is the maximum price and 29 point something is the minimum price. Whereas in the RDD, we have 299 as a maximum price and zero point 0.0 as a minimum price. So where did we mess up? Let's try to find that out. Let's go back to the problem. If you look, the problem is asking you to do filter. We did not apply filter on the RDD yet. So let's try to apply the filter because that will omit some of the records and which will take you closer to the solution that you are seeking. So for filtering, all you need to do is say dot filter and provide the filter criteria. So the filtering is based on the product price. I'm going to say x dot underscore 2 less than 100. Okay. And the next part is to fix the minimum because minimum is coming as zero point 0. Oh God. Ah, let me try to do this again. So let's try to apply the filter. Okay, filter again. I'm sorry for making you go through this again, but okay, underscore less than 100. And then the minimum is coming as zero point 0 because we are starting with 0, right? So our initialization value should be ridiculously large and long. So product price cannot be so many nines. I use so many nines. Now let's try to print the first 5 elements and see what the result is and then compare with the data frame result. Okay, now you can see 299.9. This seems to be closer to the result that we are seeking. Okay, so this finished execution. Let's try to compare the first record here. So the first record over here is 299.99, as you can see, and then 11, 11, 66.8 something, 66.8 something, and 29 something, 29 something. Now, of course, we did not format the result on the RDD, but as I mentioned earlier, formatting the data on RDD will be more time consuming and you do not have to expect such questions during the exam. However, you should expect formatting on the data frame because there are readily available ready-made functions which can be called on the data frame which will help you perform the formatting, sorting and ordering. Okay. Um, Now this concludes the part of the solution which is step number 4, which is requiring us to accomplish the same exact solution in 3 different ways. One was with the data frame, other was with by using Spark SQL, and the third was by using RDD. Now let's try to look at the next part of the problem, which is to take the solution we have accomplished and do further processing or further activity with those data sets. Okay, so the first activity is to store these in uh, in a compressed Avro file format. So for this, I'm going to use an Avro compression codec, which is snappy. So this, you need to remember how this is done, right? So I need to copy this into a particular folder. So I recommend that you memorize this statement. Okay, the statement over here is how to do compression, and the step related to setting the configuration is what you need to memorize. I'm going to change this to one partition because as you have seen in the past, every time we tried to output the result was taking a long time and the result was split into around 60 or 70 files, which was making it difficult to compare. In a real-time production environment, 60 to 670 files may be feasible, but here we're doing a simple example, so that is why I had to repartition this into one file. So let me copy this and go to Hadoop HDFS and confirm that the file that we wanted to store is in fact stored in the right way. Okay, so as you can see, there is a file which is one file because we did the repartition. Let's try to convert this into or get the result in a more human readable format. Now for that, all you need to do is use the -h option. And as you can see, it's a 1.2 kilobyte file because we enabled compression on an Avro data. That is why you received it. Now, as there, you can do the same thing on the SQL data result and also the RDD result. Only difference is for RDD, you need to convert into a data frame. You can refer to the solution all the time, which I've copied here, and paste this solution and do this for yourself. Now, this brings us to the conclusion of problem number 2 solution walkthrough. I hope you enjoyed this video.